Нет, ну, вот, понятно.
Okay, dear participants, I would like to welcome you at the defense of the dissertation of Liazat Musapirova, titled Technology of Hydrometallurgical Processing of Copper Smelter Slag, submitted for the PhD degree on a specialty 6D 07-2000 Chemical Technology of Inorganic Substances. Scientific supervisors are Professor Rashid Nadirov from the Department of General and Inorganic Chemistry of the Faculty of Chemistry and Chemical Technology of Al-Farabi Kazakh National University, Kazakhstan. Second scientific supervisor is Dr. Matej Balash, lead researcher at the Department of Mechanochemistry, Institute of Geotechnics of Slovak Academy of Science, Košice, Slovakia. The dissertation work was performed at the Department of General and Inorganic Chemistry of Al-Farabi Kazakh National University and in the laboratory of Institute of Geotechnics of the Slovak Academy of Sciences. The supervisors are present, yes?
Yes, both are present. Yeah.
Okay. Both of them are
Dr.
here.
Lunch.
Thank you. Okay, official reviewers. Dr. Omir Sirik Bagenjenov, Associate Professor at the Department of Metallurgical Processes, Heat Engineering and Technology of Special Materials. Baikonurov Mining and Metallurgical Institute, Satbayev University, Almaty, Kazakhstan. And Professor Gabor Mutsi, Institute of Raw Material Preparation and Environmental Processing, University of Miskolc, Dean of Faculty of Earth Science and Engineering, Miskolc, Hungary. So, reviewers, dear participants and reviewers, supervisors, and members of the Dissertation Council, I ask all of you to switch on your cameras because we have the recording of the defense and broadcasting on YouTube, so everybody can watch. Yeah, so we must be present, let's say, on the screen. Yeah, so reviewers, I see one reviewer is here and second reviewer, he's here. Okay, thank you. Okay, and we have also 4 temporary members of the Dissertation Council selected for this particular defense. Professor Bulat Kasenov, head of the Laboratory of Thermochemical Processes, Abyshev Chemical Metallurgical Institute, Karaganda, Kazakhstan. Dr. Hasan Arslanoglu from the Department of Chemical Engineering, Çanakkale 18 Mart University, Çanakkale, Turkey, if I'm pronouncing correctly. Dr. Tatiana Chepushtanova, head of the Department of Metallurgical Processes, Heat Engineering and Technology of Special Materials, Baikonurov Mining and Metallurgical Institute, Satbayev University, Almaty, Kazakhstan. And Dr. Alexander Kolesnikov, Associate Professor of the Department Life Safety and Environmental Protection from AWES of South Kazakhstan University, Shymkent, Kazakhstan. So what about temporary members? I see 1, 2. Dr. Kolesnikov, can you switch on your camera? And Dr. Arsanoglu also. Can you switch on your cameras? And Dr. Chepushtanova. So everybody is present. Okay, so, and we have also several, I think we have 4 permanent members of dissertation council present. So the quorum is okay. So we can start our defense. So the screen is given to the scientific secretary, Professor Sagdat Tajibayeva, for presenting the documents available in the personal file of the applicant. Please.
Thank you, both. Musapirova L.A, born in 1991. In 2013, she graduated from Al-Farabi Kazakh National University with a bachelor's degree in chemistry. Then, from 2013 till 2015, she studied as a master's student in the Department of Physical Chemistry, Catalysis, and Petrochemistry. From September 2017 to May 2020, Musapirova L.A studied in the doctoral program on the Faculty of Chemistry and Chemical Technology of Al-Farabi Kaznu in the Department of General and Inorganic Chemistry, Specialty Chemical Technology on Inorganic Substances. The topic of the dissertation research was approved at a meeting of the Academic Council of the Faculty of Chemistry and Chemical Technology of the Al-Farabi Kaznu on 26 October 2017, protocol number 3. Scientific advisors, Rashid Nadirov, candidate of chemical sciences, professor of the Department of General and Inorganic Chemistry of Al-Farabi Kaznu, and Matei Balash, PhD doctor, a leading researcher at the Department of Mechanochemistry, Institute of Geotechnics of Slovak Academy of Science, Košice, Slovakia. In the personal file of Musapirova L.A, there are copies of bachelor's and master's diplomas, a list and copies of publications, positive reviews of scientific supervisors, protocol of enlarged meeting, and all other documents in accordance with the regulation of Committee for Quality Assurance of Education and Science of the Ministry of Education and Science, Republic of Kazakhstan. The main research results on the topic of the dissertation are presented in 8 published works, including 1 article in an international journal with a non-zero impact factor. Impact factor is equal 5.039, quartile 1, according to the Web of Science database. 1 article in an international journal included in the Scopus database, and the heavy percentile above 25. 1 article published in the scientific journal recommended by the Committee for Quality Assurance of Education and Science of the Ministry of Education, and 2 patents for utility model of the Republic of Kazakhstan, 2 abstracts included in international conference proceedings, and 1 article published in an international journal. On April 20 of 2021 year, the work of Musapirova was discussed at an large meeting of Department of General and Inorganic Chemistry of the Faculty of Chemistry and Chemical Technology of Kaznu. The meeting was attended by 25 people. First reviewer, Lila Ibrashevna Sizdykova, candidate of chemical sciences, associate professor of the Department of Physical Chemistry, Catalysis and Petrochemistry of Al-Farabi Kaznu, in her positive review indicated 7 comments. And the second reviewer, Jandos Shalabayev, PhD doctor of Department of General and Inorganic Chemistry, Al-Farabi Kaznu, also gave a positive review indicating 2 comments. All the asked questions and comments of the reviewers received answers. Therefore, the scientific seminar unanimously recommended the award for defense. Extract from the protocol number 29, dated April 20 of 2021, was approved by the acting Vice Rector for Research, Professor Ramazanov Lekabul Sabitovich, in October 7th of 2021. The date of defense, official reviewers and temporary members of the dissertation council were appointed in January 14 of 2022, protocol number 7, as the meeting of our dissertation council. Many thanks for attention.
Okay, thank you. And are there any questions to the secretary or maybe doctoral student? Okay, if there are no questions, then the screen is given to the applicant to report the content of the dissertation. Please.
Okay, thank you.
The screen is yours.
Mhm. So have you seen the presentation?
Yes, we see.
Thank you. Hello, dear members of dissertation council.
Sorry, Lazat. Could you please start with the first screen because we see table 7. I feel it's
Okay.
not appropriate. Yeah. Yes. Thank you.
Is it okay?
No, now you should switch the demonstration to another window, to the full screen. Because we see the presentation, not the full screen.
Yes, I think you should start the presentation and then start screen sharing, then it will work.
F5.
Нажмите сейчас демонстрация экрана и
F5.
выберите другое окно. Нет, нажмите диссертация экрана, нажмите диссертацию экрана.
Сейчас.
Вы сейчас запустили full screen? Full screen запустили?
Да.
Ага, нажмите демонстрацию экрана, кнопку. И выберите другое окно, где full screen открыт у вас. Просто full screen в другом окне открывается, поэтому.
You can use the F5. F5.
I think that she did it, but because she
Yes, I did it.
sharing before, so she's starting to share the screen before speaking, so that's why it's problem. So she should stop screen sharing, then start with F5, and then start screen sharing, and then it will work, I think.
Yeah, the right order.
Okay.
Все заработано, да?
Теперь сделайте полный экран. Слайд-шоу. И теперь демонстрацию экрана нажмите. Нажмите кнопку демонстрация экрана. И выберите другое окно, где full screen, где на полный экран открыто.
Так.
Алло, Рашид, ты меня слышно?
Нет, нет, нет.
Вас слышно, да?
Вы нажмите кнопку, которая открывает вот это выбор, где окно, какое окно показывать. Вы же выбираете, какое окно показывать. Вот выберите другое окно, где на полный экран открыто.
Так, сейчас, подождите. 1 минуту, извините, сейчас. Так, теперь попробуем еще раз. Теперь.
Yes? Now it's
Is
okay?
it okay? Is it okay?
Yeah?
Okay, sorry. Hello, dear members of Dissertation Council. Let me introduce dissertation work title, Technology of Hydrometallurgical Processing of Copper Smelter Slag. Copper smelter slag is a byproduct of pyramidological copper production. Annually, more than 50 million tons of slag are produced in the world, and including more than 500,000 tons of slag are produced at Balhaj Copper Smelter in Kazakhmys Corporation. This is copper smelter slag is processed with flotation enrichment, and this is process flotation enrichment doesn't the relatively low content of copper in copper concentrate and as well as almost completely loss of zinc doesn't allow us to consider it as an acceptable method. Another method, it's a pyramidological method. It is a slag depletion in electric furnaces. This method is economically not feasible due to high energy consumption. So we decided to use hydrometallurgical methods because hydrometallurgical processing doesn't demand so elevated temperatures and techniques like in other methods. And the hydrometallurgical methods is the processing of material with an aqueous solution of chemical reactions, and this method seems attractive. Goal of the work, it's find optimal conditions for mechanical activation of copper smelter slag and its subsequent sulfuric acid leaching, providing high extraction of copper and zinc into solution. Tasks of the work: determination of a model describing the leaching, or effective potassium dichromate on metals recovery, revealing the influence of dry and wet mechanical activation on the change in specific surface area, revealing the effect of mechanical activation of copper smelter slag on metals recovery, optimization of conditions for mechanical activation and leaching, and the development of a schematic diagram. The object of the research is copper smelter slag samples collected from the Kazakhmys smelter. The subject is the processes occurring during wet mechanical activation and dry, as well as during leaching. The dissertation work was carried out mainly at the Department of General and Inorganic Chemistry, Institute of Geotechnics, Slovak Academy of Science, and in the Institute of Combustion Problems. The general idea of research consists of three stages. At the first stage, initially, slag sample was leached with aqueous solution with sulfuric acid, and without any additives and without slag pre-processing. It is found that the recovery of copper was not so satisfactory, even in elevated temperatures, so it's needed additional oxidizing agent like potassium dichromate to increase the leaching ability of the sulfuric acid solution. Then in the third stage, to increase the reactivity of the touched materials, attrition and the planetary bone meal was used to increase the specific surface area of the slag sample and to subsequent sulfuric acid leaching. In the first stage, in the sulfuric acid leaching, as we can see from this figure, we can see metals recovery in the different temperatures and during this time. As we can see, values of metals extraction after 1 hour leaching didn't increase. So above 60 degrees, the increase of temperature had no practical effect on metals recovery. The maximum recoveries for copper was about 50%, and for zinc and iron was about 80%. Then this is chemical reactions occurred with this is the minerals in the slag sample. In order to understand the kinetics of the process, shrinking core model was applied. According to the shrinking model, we have straight lines according to this is equation versus time, depending time. So this is straightforward lines indicate that the limiting stage of the process was chemical reaction. And we have calculated the kinetic parameters of metals recovery into solution. From this table, we can see that higher the temperature, higher the rate constant, and we calculated the activation energy. So brief conclusion from the first stage that increasing the temperature and the duration of leaching to particular values resulted in an increase of metals recovery. Sulfuric acid leaching at ambient temperature provided extraction of copper and zinc only about 16 and 20% respectively. Heating the solution to 70 degrees increases extraction of measured metals about 50% and 45% respectively. And it's found that limiting stage is chemical reaction stage. However, in sulfuric acid leaching, we use elevated temperatures like 70 degrees. So then, in order to conduct our experiment at ambient temperatures and to increase the leaching ability of sulfuric acid solution, potassium diachromate was used as an oxidizing agent. From this dependence, we can say that potassium diachromate had a positive effect on copper recovery. As we can see, as concentrations of diachromate increases, the copper recovery increases simultaneously and reached about 80%. On the contrary to zinc and iron recoveries, on this occasion, their recovery was about 4 and 5% respectively. This is chemical reactions occurred in sulfuric acid solution in the presence of potassium diachromate. And as a brief conclusion after the second stage, that the presence of diachromate has a negative effect on zinc and iron recoveries. Presumably, this fact is due to absorption of diachromate ions on the mineral surface. Under these leaching conditions, copper recovery was about 70%, as well as zinc iron recovery were 4 and 5%. When applying small concentrations of sulfuric acid and the potassium diachromate, only around 10% of copper was recovered. So, in order to reduce potassium diachromate consumption and improve reactivity of target component, mechanical activation was applied. So assumptions for applying mechanical activation was to increase specific surface area, to give additional energy, and to obtain particles with more reactive abilities. In mechanical activation, two types of mills were used, and two types of modes of milling, dry and wet milling, were used. It's a planetary ball mill, this is experiment conditions, and the attrition mill. The experiments in attrition mill were performed at the Institute of Geotechnics of Slavic Academy of Sciences. So this is mineralogical and chemical composition of the starting slag before mechanical activation. As we can see, the major phases were fairly and the ferrite zinc, and the minor phases were chalcopyrite. This is the influence of mechanical activation on some physical properties of the slag. As we can see from this is the figure 8, particle size distribution. The particle size of the starting samples varies in 100 and 1000 millimeter in size. And after the mechanical activation, the curves have a bimodal distribution has been observed with the two maxima in 1 and 100 millimeter. The magnetization properties were altered after mechanical activation. As we can see, the milling process results in noticeable reduction. This is the starting and a noticeable reduction in the specific magnetization due to defects, introducing defects, and this reduction may reflect the decrease in the particle size and the increase in specific surface area, as it is known that surface atoms have reduced magnetic exchange coupling. So at the first, mechanical activation was performed in a dry mode. As we can see from this figure, we can see that the planetary ball mill the sample was treated under planetary ball milling. Activation has a greater disorder than attrition milling. It is due to high energy applied. From these tables, we can see that when we increase the duration of mechanical activation from 2 minutes to 100 minutes, the specific surface area value was decreased, and this is due to the agglomeration process. Agglomerate formation is common during dry milling because due to the tendency of the activated materials to reduce its surface free energy. But despite the better results obtained at planetary ball mill, it would be difficult to use this type of mills at industrial scale. So we decided to do leaching and mechanical activation with attrition milled slag samples. And consequently, we have performed the milling under wet conditions in a treater. So we have obtained SSA value about 13 meters per gram has been observed. This type of mill attrition was chosen for further optimization about mechanical activation in wet conditions. For optimization of mechanical activation, Taguchi design was used. This method uses signal-to-noise ratio to measure the variations of the experimental design. This is equation, the larger is the brighter equation, was used to calculate signal-to-noise ratio for each factor. A larger is better was chosen as the largest values of specific surface area were the desired in the terms of good leachability of slag. So 3 factors were chosen for mechanical activation, and 3 levels were chosen according to Taguchi design. From optimization of wet milling in attrition mill, we have obtained these values. So we can see that wet milling have greater SSA values than dry milling, and in this case, experimental M9 have a greater SSA than others, about 60 meters per gram. Wet milling, so the optimization of mechanical activation conditions were conducted with Minitab software. From this software, we can see the optimal conditions for mechanical activation. This is 1200 RPM and so on. From this figure, we can see contribution of each factor for mechanical activation, and from this we can see that the rotation speed has a greater influence on mechanical activation, about 90%. So from this provision done, we can conclude provision 1. Wet mechanical activation of copper smelter slag in both mills in planetary ball and attrition mill leads to a more significant increase in its specific surface area than dry mechanical activation. Then, under these optimal conditions, the mechanical activation were conducted for planetary ball milling, and we have obtained this is SSA 126 meters per gram. And with both samples, the leaching experiments were conducted. From this leaching experiments, we can say that higher copper recovery was observed for planetary millet sample. It's about 80%, and highest copper selectivity was observed for attrition millet sample. It's about 90%. So in this Taguchi design, the main factors were, the 4 factors were, and as the same as previous mechanical activation, the main 3 levels, upper, lower, and medium was selected. After Minitab software, we can conclude about the optimal conditions for copper recovery and for copper selectivity in both mills. With this experimental setup, we can conclude that with this technique we can obtain the slag with with the highest copper recovery and with the highest copper selectivity, as well as predicted means and experimental means for copper recovery were almost the same. So after sulfuric acid leaching in the presence of bichromate, we decided to investigate the effect of potassium bichromate on the leaching. In order to understand this, we decided to perform to perform experiments without potassium diachromate in the absence. So we can see that in order to understand that recovery with in the absence of potassium diachromate was significantly lower, and that indicates that potassium diachromate has a greater influence on the recoveries. And so we wanted to investigate mechanical activation on the corpus recovery. So we used non-millet slag, and have conducted the same conditions for the recovery for attrition mill and for planetary mill. As from this, we can see that the mechanical activation was also beneficial for sulfuric acid leaching. From this, we can conclude provision 2, dry and wet mechanical activation of corpus metal slag increases the degree of metals recovery into solution during sulfuric acid leaching. So, potassium diachromate, being a great oxidizing agent, should oxidize metals, especially in sulfuric acid solution, because we said about the absorption process. So we have our hypothesis that was the kinetics maybe play a role here for dissolution of minerals in sulfuric acid solution in the presence of potassium diachromate. So we conducted additional experiment under the condition providing a higher scope of recovery. However, the leaching time in this case was 8 hours. For previous case, it was only 1 hour. So the extraction of metals into solution was found about for zinc and iron was about 80 and 70%, and for copper about 80%. That's indicating that kinetics plays a role here. Thus, from this, we can conclude provision 3, the presence of potassium diachromate increases the degree of metals recovery from original and mechanical activated corpus metal slag during sulfuric acid leaching, and provision 4, leaching of corpus metal slag in sulfuric acid solution in the presence of potassium diachromate makes it possible to selectively extract copper into solution. This circumstance is caused by the higher dissolution rate of copper sulfide minerals in comparison with the dissolution rate of iron, mainly fayelite and zinc ferrite minerals under the investigated conditions. Then, in order to industrialize it, our scheme, our methodological setup, we lowering LS, liquid solid ratio, into 10, and we propose that this is principal scheme for recovering at the first stage copper and at the second stage zinc. Initially, as the first, we have mechanical activated in attrition mill under optimal conditions, our slag sample. Then it will be crushed, and it will be crushed and then wet mechanical activated. Then goes to the leaching, and this is optimal conditions. Then the salt liquid separation occurred. Salt residue goes for zinc recovery, and copper solution goes to the copper precipitation as like cementation or sulfate precipitation. In the second stage, salt residue after slag leaching with containing zinc and iron goes to the leaching under this is the mentioned conditions above. And go to the salt liquid separations, solution containing salt residue goes to the Leica residue, and the solution with containing zinc and iron goes to the removal of iron. Removal of iron could be accomplished in pH to 2.25 with these reagents in the form of Urazid. And in the finally, we can obtain zinc rich containing solution for further recovery. From these two principal schemes, we can recover about 80% of copper and about 70% of zinc. And as the conclusions, Based on the data presented, the following conclusions were made. At first, the rate of leaching of these metals into solution at all studied temperatures was controlled by the rate of chemical reaction. The presence of bioformate in sulfuric acid allows selectively separating copper from zinc and iron. Copper recovery is highly dependent on copper-bearing mineral present in slag. Cavellite and chalcocite are more easily leached than chalcopyrite. A dry and wet mechanical activation of copper smelter slag in both mills resulted in enhancement of specific surface area. Leaching of both initial mechanical activated slag and sulfuric acid solution in the presence of potassium dichromate made it possible to selectively extract copper. The selectivity is due to higher dissolution rate of copper minerals. The samples obtained using optimized conditions have been subjected to leaching, and this is optimal conditions were determined. Under these conditions, copper recovery reached about 90%, the copper selectivity was about 95%. So this predetermined the proposed methodology to be potentially applicable in the industry. And the technological scheme of hydrometallurgical processing of copper smelter slag is proposed. Thank you for your attention. This is a list of publications I have written. Thank you.
Okay, thank you. Please do not close.
Okay.
So please do not close. Open it back. Okay, thank you. And what about questions? Colleagues, if you have questions, just raise your hand. Questions? Okay, Dr. Hutoryansky.
Okay, thank you very much. Can you please explain how have you calculated specific surface area?
It was done with bed measurements, and so we did it in experimental setup, this was done in the Institute of Geotechnics in Slovak Academy of Sciences. So we did it in experimental setup.
Okay, thank you.
Thank you. Okay, Dr. Chepushtanova, please switch on your camera. Why we don't see you some way? Okay, please.
Hello, everyone. May I ask you one question about the scientific novelty? How do you think, what the scientific novelty is your work? And the first main position of the scientific novelty that I received by abstract, as you know, please explain what is the new result and what is the novelty in the main kinetics parameters which you define of the reaction of copper, zinc, and iron. Because there is no one conclusion, no one some numbers in the formulation of the novelty. I didn't see. Please explain all your positions about the scientific novelty and explain what is the novelty of your work.
Thank you for the question. The scientific novelty of done work is that mechanical activation, simultaneously mechanical activation and potassium dichromate were used in the setup. And before this work, there were no results about this. It was done some works with a converter slag, but it differs from our slag with mineralogical composition and elemental composition. The content of copper in converter slag was much higher than ours. And the second novelty, it was that we proposed a new idea for explanation about selectivity of potassium dichromate. We explained it about the difference in the rates of minerals dissolution. It's about copper minerals, chalcopyrite, and about iron and zinc minerals. About the kinetics, it was the calculation of kinetic parameters for exactly this slag were not done before. And this is the calculations maybe have give us about the difference in activation energy. As we can see from our table, the activation energy for iron compounds were lower than for copper and zinc compounds, and that indicates that it's concerned about minerals about the form as iron consists, because iron mainly is oxides as an oxides present, and the copper and the zinc is mainly present as sulfides. As we know, sulfides is not so readily soluble components.
Do you listen to me? Can I ask?
Okay, yes.
Dr. Cheposhtanova, do you have other questions?
Yes, I have.
No, Dr.
What,
Cheposhtanova.
do you listen to me?
Yes, I hear you, but
because I had some problem with my microphone before.
Yeah, I'm sorry, Mukash Murzabavich. So Dr. Cheposhtanova has to finish.
Okay.
Okay. We don't hear you, Dr. Cheposhtanova. Can you switch on your microphone?
Yes.
Okay.
So I want to finish. Your confirmation about the possibility of the selective extraction of copper. What certain conclusion about this possibility? What is the conditions, and what is the final results of this possibility? There is no data in your novelty in the abstract. I can find this, and I think that you should to introduce some numbers of these possibilities and to prove this possibility, because of this formulation of the novelty, there is no scene, and we can do some conclusions about this.
So, okay, thank you. As I said, the possibility of explanation regarding the selectivity is related with the different dissolution rates of presented minerals in proportional slag. In our case, we did an additional experiment about the kinetics in order to understand the selectivity. In this additional experiment, we have done experiment with a longer duration of leaching. It was 8 hours. Because in our previous work, it was only 1 hour or 2 hours. In this present case, we selected 8 hours in order to understand is kinetics plays role or not. So from this is a result, we can say that after 8-hour treatment, after 8-hour leaching treatment, the recoveries of zinc and of iron was as the same for copper. And so in order to selectively extract the copper from the solution, we need predetermined durations and the conditions. So it is a main explanation for selectivity. It's about kinetics.
And nobody do before you this?
Yes.
Do you know there are different types of technologies which was elaborated in the Institute of Metallurgy? Do you know the Kvitkovsky, Professor Kvitkovsky result?
Kvitkovsky, I know about this methodology in Turkish institutes. It was about using potassium diachromate, but they explained it's about adsorption. But this is explanation isn't so unclear for us, wasn't so unclear for us, because in this is circumstances, in this is they conclude that this absorption maybe it's an infinite matrix and it's a finite matrix, and the copper is in separated phases in copper slag content, and it was not so so clear for us in this is explanation. And potassium dichromate is a strong oxidizing agent in sulfuric acid media. It will oxidize all mentioned metals. So this passivation effects has a temporary role there. We know this works, and we have did all our research regarding this work, and just to declare our hypothesis about selectivity.
I don't see the difference between your work and works from Institute of Metallurgy. Thank you very much.
Okay, thank you. Okay, Professor Burkitbayev.
So thank you, Lizette, for your very clear presentation. My question, I have several questions, and one of them deal with the previous questions made by Chipushtanova. Have any previous work have been carried out on the use of mechanochemical activation of slag, followed by leaching with the acidic oxidizing solution? This is the first question. And the second one, this work is oriented for the practical application. And from that point of view, have you conducted at least approximation economical assessment of that process? And because from the energy point of view, mechanical activation requires huge energy, and even more, bichromate also is not a cheap chemical reagent. And a third question is just for maybe your future activity. What do you think if we will add not just bichromate, also if you will add some substances which give good complexes with copper, because copper is a very good complex formator, and I think it's not difficult to find some strong ligands which is accept the support for leaching of copper from the mechanical activated slag. This is my questions. Thank you.
Okay, thank you for the questions. Regarding first question, mechanical activation was applied in another type of slag with another oxidizing agent as ammonium persulfate, and others with sodium chloride and others. But in their cases, they use elevated temperatures. In our case, we conducted all experiments at ambient temperatures, and the recoveries in their case was only about 60% and 50%. It's not so high as in our case. Regarding second questions about potassium dichromate, yes, I agree that it is some toxic compound, but in our days, we have residuals from different factories with this is chromium wastes. So this will be our contribution in order to reduce to convert chromium 6 plus. This is a toxic compound 2. Chromium 3 plus. This is a less toxic compound. In our case, as it is oxidizing agent in sulfuric acid solution, it will have reducted its ion, so it is valences. So we can resolve this problem about chromium residue waste disposals. And about economic performance, this is set up. As you can see, we have performed principal scheme. In this principal scheme, I assume we cannot do something economic calculations due to it is about aggregates, it's about techniques, it's about some equipment for the technology, and in this case we proposed principal scheme. But however, from our results, we can see that that this is proposed methodology is economically very feasible, very high, because our recovery and our selectivity was highest. It's about 80% and 90%. About complexity, about the ability for complex forming with another ligand, I assume that it will be organic acids. So I think that organic acids, it is not so, the amount of organic acids not so high, because sulfuric acid leaching, the beneficial sulfuric benefits of sulfuric acid leaching, that the amount of sulfuric acid is very high, and it is a byproduct of pyrometallurgical processing of copper metal slag in Balkhash copper plant. So this is my answers.
Thank you.
Thank you.
Okay, thank you. Okay, next. Who is next?
Можно вопросы?
Yes, please. Пожалуйста. Влад Кунурович.
Одну минутку. Так, Ляззат Архатовна, скажите, пожалуйста, здравствуйте. Скажите, пожалуйста, вот у меня несколько вопросов по кинетике. Энергоактивация реакции выщелачивания меди, цинка, железа равны, соответственно, 28,1, 23,1, 16,5 килоджоуль на моль. Это результат первый. А извлечение по показателям энергоактивации должно быть высокое у железа, потому что мало энергетического барьера. Так? А у вас у цинка больше. Почему? Это первый вопрос. Это по кинетике, можете сразу ответить на все сразу. Энергоактивация определяется при такой температурной зависимости, обычно температура, строится график зависимости рентгеновских координат. Да. Это логарифм К с скорость от обратной температуры и, соответственно, описывается уравнение логарифм КС А минус Б деленное на Т. Что-то этих графиков я не видел и уравнений не видел. А как определялся энергоактивация? И третий тут дополнительный вопрос. Эти данные, которые вот получены энергоактивацией, кинетические характеристики, находятся в обратной зависимости с участием бихромата калия при извлечении меди 34,2, цинк 2,1 и железа 4. Почему? Пожалуйста.
Спасибо за вопрос. Насчет первого вопроса, насчет извлечения железа. Тут у меня получается железо, он в виде минерала фаэлит. При сернокислотном выщелачивании у нас образуется кремниевая кислота, а как мы знаем, кремниевая кислота – это поликислота, получается, у нас идет полимеризация, и таким образом у нас идет пассивация. В дальнейшем этот слой пассивации, он препятствует растворению именно этого минерала. Насчет второго вопроса. В диссертации это приведено. именно вот это уравнение Арениуса, да, мы также его высчитывали, графически это все находили. И насчет третьего вопроса, насчет бихромата калия, насчет селективности, тут идет обратная зависимость, в зависимости от того, что при разных условиях, именно при условии liquid solid было там 75 и так далее, при этих заданных условиях у нас именно медь, имеется в виду, она селективно извлекается от железа и цинка. Это связано с кинетикой. Получается, фаэлит и минералы феррита, они более упорные именно к этому реагенту, нежели чем халькопирит.
И еще один вопрос, можно?
Да, пожалуйста.
Вот выносимые основные положения на защиту. У вас первый пункт, вот в первом пункте говорится, что мокрая механическая активация отвального медного шлака планетарной мельницы и от тритера в большей степени увеличивает удельную поверхность материала, чем сухая. То есть вы отдаете предпочтение мокрой механической активации. Так? А теперь во втором положении сухая и мокрая механическая активация отвального медного шлака увеличивает. То есть они одинаково увеличивают. Может, местами поменять? То есть вы сначала делаете сухую мокрую, а потом даете на основании исследований, вы мокрой механической активации даете предпочтение. Может, просто местами поменять нельзя?
Имеется в виду как логически, да, чтобы было?
Да, вы сначала проводите сухую, мокрую, и они оба увеличивают, но потом вы даете предпочтение мокрой механизме. А у вас, может, местами поменять надо. Мне кажется, вот второй пункт надо на первый, а первый на второй.
Хорошо. Ну да, логически это такие есть.
Логически должно быть. Вы же альтернативно, да, потому что проводите ее мокрую, сухую, а потом даете предпочтение мокрую. А у вас, получается, вы сначала мокрый даете предпочтение, а потом опять сухой и мокрый даете предпочтение.
Просто мы изначально, когда проводили все эти эксперименты, мы изначально определяли именно спецификс удельную поверхность, а после уже делали выщелачивание. Получается, эти выводы у нас уже пошли дальше, после как мы определили влияние механоактивации на удельную поверхность. Поэтому вот и такая последовательность. Вот. Но да, на самом деле мокрая механоактивация, она больше значимой степени повлияла на выщелачиваемость минералов, нежели чем сухая механоактивация.
Ну, тогда можно поменять, да, местами, или как? Вы остаетесь своим мнением. Хорошо. Да, спасибо.
Спасибо. Okay. Other questions?
Извините, а я могу задавать вопрос?
Yes, please. Да, конечно, пожалуйста.
Ага. Здесь вот появляется вопрос, как вы сказали, при выщелачивании образуется кремниевая кислота. Плюс к этому, если учесть, вы выщелачиваете механоактивированные мелкие частицы, появляется вопрос, а как вот с процессом фильтрации? Насколько нам известно, даже вот присутствие кремниевой кислоты 0,3–0,4 грамм на литр, это существенно усложняет процесс разделения фаз жидкой и твердой фазы. И это обуславливает неприменимость технологий в больших объемах в производстве.
Спасибо за вопрос. Да, вот именно в этом случае, когда мы проводили выщелачивание серной кислотой, у нас появлялась вот эта пленка именно поликремниевой кислоты. После механоактивации именно с этим образцом и при сернокислотном выщелачивании именно этой пленки у нас не было. Получается, мы именно используем механоактивацию для предотвращения образования поликремниевой кислоты. Получается, тут у нас не только тут идет аморфизация, и идут некоторые химические процессы, которые препятствуют появлению поликремниевой кислоты, образованию поликремниевой кислоты. После этапа механоактивации именно этой пленки у нас не образовалось, оно способствовало к аморфизации и дальше к выщелачиваемости для фильтрации, более удобно.
А как вы это можете объяснить? После механоактивации это наоборот должно увеличиваться образование кремниевой кислоты.
Так, нет, у нас получается после механоактивации именно фаэлит, он аморфизировался, почти этих пиков у нас не обнаружилось. Феррит, он остался почти таким же, он был очень упорным минералом, но именно фаэлит, он у нас аморфизировался. Возможно, что оно распалось на оксиды железа и кремния, и таким образом у нас, получается, не образовалось поле кремниевой кислоты.
А содержание кремния в растворе вы анализировали?
После выщелачивания?
Да.
После выщелачивания кремния было меньше. Анализировали, но сейчас так точно...
Просто меньше — это вот не ответ. Тут конкретные цифры нужны, сколько граммов в литре образуется, появляется. И, как вы сказали, вот аморфный кремнезем, наоборот, усложняет процесс разделения фаз по сравнению с кристаллическим кремнием. И вот, судя по этим данным, которые вы говорите, что вот образуется кремниевая кислота, образуется кет, который не растворившийся остаток, он аморфный. И...
Не растворивший остаток, он не аморфный, он кристаллический. Именно аморфная часть у нас растворилась. Вот для этого и проводилась механическая активация.
Аморфная часть кремния, имеете в виду, да? Имеете в виду аморфный кремний? Ага.
Нет, я имею в виду именно минералов фаэлита и для халькоперита.
Ну, фаэлит — это кремний содержащий минерал.
Да. Но у нас по рентгенофазовым данным получается то, что в некоторых источниках данных было написано, что фаэлит, он при механоактивации распадается на оксиды, и таким образом они предотвращают появление именно этой пленки. У нас фаэлит, он хоть в случае бихромата, он, получается, не вступал в реакцию именно в тот момент, именно при 1 часа. И получается, что железо, оно не до конца аморфизировалось.
А скорость фильтрации вы не рассчитывали, да? Сколько кубов проходит через квадратный метр в промежуток времени? Это очень важный момент, скорость фильтрации.
Нет, мы это не рассчитывали. Так как у нас уже главная наша цель, это была извлечение именно меди и цинка в раствор.
Ну, чтобы дальнейшее применение в производстве, это очень обязательный фактор. А то вот то, что вы извлекли раствор, если не сможете отделить от нерастворившего остатка, это уже ни о чем не говорит.
Ну, просто при входе эксперимента я сама не сталкивалась с такой проблемой. Я знаю, что когда мы механоактивацию не проводили, была такая проблема, прямо образовался этот слой. А после механоактивации я могла именно процесс фильтрации, он проходил легко.
А на чем вы фильтровали?
Я на обычной фильтровальной бумаге, это был как бы лабораторный эксперимент. И он как бы прошел, имеется в виду именно через эту фильтровальную бумагу, это не занимало много времени.
Ладно. Спасибо. Да, но фильтровальная бумага-то разная бывает. На какой именно бумаге фильтровали?
Именно на желтой. Желтой и синий по-разному.
Синий это совсем
синяя более плотная, да.
Окей, спасибо. Okay, what about other questions? Okay, I have several questions. First question is about standard deviations. So in your data, in your presentations, I didn't see any standard deviations. Did you repeat your experiments? Did you make sure the results are reproducible?
In the beginning of the experiments, we have optimized leaching conditions, so it was 9 experimental runs. For this, it was predetermined. It was it was previous experiments in order to understand what leaching conditions is preferable in our case. So this is 9 experiments, didn't repeat it, have not been repeated. Then the last stage with the optimal recovery and the selectivity were repeated, and the determinate values for the copper, recovery, zinc recovery, and the iron recovery were determined with the error 0.05. This is a metals recovery were determined with the atomic absorption spectrometry method. And this was standard deviation with regard to this equipment.
What was the standard deviation? 0.05. What units?
Percent. Yeah, percent. It was.
But did you make, for example, 3, let's say, extractions, and then you get 3 results, and then calculate the standard deviation? Did you do it? I don't ask about the 3 measurements of one solution. I ask about 3 different experimental samples. Yeah, so because you know this, you can have some uncertainty in the extraction process, in the recovery process. Yeah, so what was the uncertainty in this process?
Yes, we have did 3 leaching experiments in the same conditions, in the same optimal leaching conditions, and we obtained the values determined with atomic absorption spectroscopy, and the deviation from this between these values was 0.5%. It was percent. It is the mean for recoveries, for metals recovery.
Yeah, but it's impossible to have such an accurate extraction, really. It's really. Do you have the data? Can you show it to us? About what date? Maybe dissertation or where?
In the dissertation, it was in the I have mentioned about this in the experimental part. And this is mean. This is values. This is mean values. The mean values was determined in the presentation.
Yeah, but what was the standard deviation? I don't see.
Standard deviation. I haven't calculated exactly standard deviation.
For example, can you open the table 7? Can you open the table 7?
Table 7.
In your presentation, in your slides.
Okay. This is.
I don't see. So you should share your screen.
Yes. This one.
Okay, next slide. Next.
This one.
Yeah, you provide, the value 68.19. Yeah, for example, for zinc.
Yes.
Yeah.
Yes.
What was the uncertainty in this value? Did you repeat it 3 times?
In this case, the uncertainty was about, so we have obtained about 69 and 70%. And so the uncertainty was about not so about 0.02, 0.03 like this. But we didn't did this 3 times. We did this only 2 times because the long duration of leaching time was.
Okay, yeah, but I'm asking because you provided 4 significant figures, and the number of significant figures should depend on the uncertainty in this value.
Okay.
Yeah, so why did you decide to provide 4, not 3? Not for example 68.2. Yeah, so you can make it 68 or maybe 68.2, but you wrote 68.19 for zinc. Why did you choose to write like this?
This was means, so this is two observed values, and this is why we have obtained this value.
Yeah, but each value which you report, it should it should show the error. Yeah.
Okay.
So if it really depends. It's completely different numbers obtained with different accuracy.
Okay.
Okay. Can you show table 7?
This one.
Yes. So I think I see recovery of copper is like 20%. It's very low.
Yes, it's
why? But you wanted some higher values.
Yes, because this table 7 showed us the leaching recoveries, metals recovery in the absence of potassium diachromate. In order, I wanted to show that the potassium diachromate had a positive effect on copper recovery. When in the absence of potassium diachromate, the recoveries were lower than in the present.
What recoveries did you reach? In the presence of zinc and iron, in the presence of potassium dichromate.
Yes, this is.
Okay, you get like 90%. Was the highest?
Yes, it's for copper. It's 90%, experimental about 90%, and selectivity about 95%. And without, it was only 25 and 30%.
Okay, but what about other commercial technologies? What recoveries they can provide? Probably there are other like similar technologies to your technology. Yeah. What recoveries are typically achieved?
In similar technologies, they have achieved about 60%, about 50%. Their upper recovery was about 60%, but they had reached about 70% also in an elevated temperatures with the use of roasting, with the use of heating, and their technologies demands more high energy techniques than this is experimental setup.
Okay. I have another question about the limiting stage. You said that limiting stage is a chemical reaction. Yes. In the beginning of your presentation, yeah?
Yes.
But I see no evidence for that. You just said, okay, it's chemical reaction.
It's about shrinking core model. It's regarding this.
What's the reason?
Yes.
What's the reason? Can you prove it that it's chemical reaction?
Yes, we applied shrinking core model for investigate the limiting stage of the process. As we can see from this equation, we have linear tendencies for all the mentioned metals, and this indicates that the limiting stage is chemical reaction.
No, but other processes can also provide similar plots, you know, not only chemical reaction. So this is not an evidence.
But yes, we did another two linear dependencies, but we don't have this results in the last cases, in the other cases. So we decide that in order to this is a linear tendency, we have concluded the chemical that the process is governed by chemical reaction stage.
Okay, what order of reaction do you have?
This is the main reactions.
What is the order of reaction?
The order of the reaction is 1. It's first order.
First order reaction.
First order.
Okay, yes. Thank you.
Thank you.
Okay, dear colleagues, do you have questions?
Yeah, can I have?
Yes, Professor Khutoryansky.
Can I show the screen? Because my question is about the thesis. Just give me a second.
Can you close the slides?
So do you see my screen now with the thesis?
Professor Khutoryansky wants to show.
I just need to close my, okay? Okay.
Do you see the figure 1.1?
Yes.
Yeah. Well, first is a minor thing. I guess it's just a mistake because you're referring to figure 2, then figure 1.
Yes, you are right. It was there. Yes.
But second thing is, if I read this discussion, is it about this figure?
Yes, it's about consumption.
Okay, so if we read it, the additional hydrogen peroxide in an amount of 60 liters per ton. So we're talking about this data point, right?
Mm-hmm.
Increase the copper recovery to 76%, which I agree, it is roughly 76%, but 7% more than in the absence of hydrogen peroxide. And I assume that absence of hydrogen peroxide will be this data point, isn't it?
Mm-hmm.
So is it 7% more? Here is 76, he is slightly under 60. So it's definitely not 7% more, but a bit bigger.
Yes. So maybe it's a literature review, and maybe yes, I have some typos from this.
I guess you need to rewrite this bit, but then since
okay.
Using this figure in your literature review, I guess discuss it in a greater detail, because you're talking about copper only. Well, you mentioned in zinc, and zinc also, I would question this statement, because you're talking about zinc also passes into the solution. However, iron is retained in the leaching residue. But then if you look at iron curve is this one, and surely if you're referring at 60 liters per ton, then you still have around 10% of iron recovery, which means that iron is not fully retained, but it also recovers. Am I right?
Yes. In due time, it recovers too.
And I think you need to expand this discussion. Well, you need to revise it and expand it very slightly, because clearly there's a difference between the behavior of iron versus copper and zinc, and possibly it will make sense to explain why there's a difference also. Okay.
Okay.
Thank you.
Okay, thank you.
Thank you.
Okay, more questions? Okay.
Just for attention of Lizat. Lizat, please take a look at page 28 of your thesis. It seems to me it is some mistake in the equation writing, but it's just for you. It's not necessary to answer.
Okay. I will look about this page.
Okay, colleagues, but okay,
check the equations again. Okay.
Okay, now we have the questions only, so you can mention this during discussion. If you have some comments to the dissertation, yes, so we can discuss them later. Okay, colleagues, if you have no question, so the floor is given to scientific advisor, to the first scientific advisor, Professor Nadirov. Please.
Thank you, Vladimir Romanovich. So, dear colleagues, we began to deal with these issues of leaching copper slag at the chemical faculty of Kazakh National University more than 10 years ago, and this direction indeed is very promising from the commercial point of view. In 2017, I proposed this topic to Lazat for her doctoral dissertation, and Lazat agreed. And really, Lazat did a lot of research work during her doctoral studies. Some hypotheses were confirmed, something did not quite work out for us. But to increase the reactivity of zinc and copper minerals, mechanical activation of the material was first proposed. Lazat and I were lucky to meet Matej Balash, who kindly agreed to become Lazat's foreign supervisor, and a significant part of the work was carried out at the Institute of Geotechnics. And we also, Lazat and me, we also consult with Peter Balash, who is one of the most well-known specialists in the field of mechanical activation in hydrometallurgy. But generally, I think that Lazat successfully performed with her work. And many thanks for reviewers and members of the Dissertation Council for their attention to LAZAT works. And let me have some comments on the briefly, some comments on several comments of reviewers. First of all, I would like to reply to comments of Dr. Chipushtanova about differences between our work, LAZAT work, and the work performed at the Institute of Metallurgy. And this question has a very simple and short answer. Professor Kwiatkowski and other specialists in this institute work with pyrometallurgy, but LAZAT work with hydrometallurgy. Is completely different, but the object is the same, yeah, the slag, but the methods are completely different. So it's a completely different areas. And so regarding to comments of Professor Dr. Baginzhenov, really, на самом деле, let me please reply in Russia, это действительно большая проблема. Профессор Багинженов обратила на это внимание, но она на самом деле сейчас практически нерешаемая, то есть фильтрация такой пульпы после сернокислотного вычелачивания тогда из огромнейших проблем. И мы на самом деле мы ее тоже не решили, и как бы так она существует, но это не была наша задача, то есть это диссертационная работа, мы выполнили какую-то часть. So thank you for your careful attention to this work, and thank you. That's all.
Okay, thank you, Professor Nadirov. Do you have questions? I have a few questions about the input of Ms. Musapirova to the publication, which was published in the Journal of Materials Research and Technology. Yeah, so what exactly was done by Ms. Musapirova?
It is question for me or for Matei?
Yeah, to you. Question to you.
For me.
Yeah.
LAZAT performed mostly. He performed all experimental works. So not only experimental work, but also the processing the results and the drawing the graph and so on and so on. And I guess her contribution is very high. It's very high. He acted as the first author. Matei Balash was the corresponding author, and LAZAT was the first author. And that's, I guess, her contribution is very high. It's very high. Maybe I cannot say the percentage, because we have maybe 5 or 6 authors, but co-authors, but her contribution was very high.
Okay, thank you. Thank you. So if you have no questions to Professor Nadirov, then the screen is given to the second scientific advisor, Dr. Matei Balash, please.
Okay. Hello, everyone. So thank you very much for the introduction. My collaboration with LIAZAT was very beneficial also for me, because as also Professor Nadirov mentioned, so hydrometallurgy is not my field of expertise, but my father, who I am still working with, is a good expert in this. So thanks to this, I could receive also some very important knowledge. However, I had some experience with using mechanical activation for various materials, and I think in this case it was pretty useful. With regards to the collaboration with LIAZAT, so I have to say that she was really hardworking, and she was very quick in learning new things, because she never had seen an attrition mill before coming here, and she was able to learn how to operate it by herself. It may be after 2 or 3 experiments, which she was collaborating with our technician here. And then she was also very quick to, let's say, put down some notes about the experiment and complete like preliminary draft of paper. This was also, I was really surprised to see this. She's really a hardworking person, and with regards to the whole PhD study and the thesis as it is, I can see that there is, let's say, different standard in Kazakhstan. I would say this level of PhD, also the work and the distance is higher than here. For me, I think the work is written well, and it contains really a lot of data, both from literature and both from the experimental point of view. As far as I have seen this discussion, I can see it's also very useful for Riyazat because there have been more critical points raised here. So I'm sure it will help her also to potentially improve the thesis, but mainly in her future work, because as far as I know, she would like to spend the future in scientific field. So I think that is all from me. And I am here if there will be any more questions about our collaboration. Thank you.
Okay, thank you very much. Any questions to Dr. Balash? Okay, thank you. If there is no question, then we can proceed to the next stage, and the screen is given to the first reviewer, Associate Professor of the Department of Metallurgical Processes, Heat Engineering and Technology of Special Materials, Baikonurov Mining and Metallurgical Institute, Dr. Baygenjenov. Please, the screen is yours. Okay, just one comment. Just you don't need to read it. We are interested in your opinion about the work, general opinion, maybe some comments about the dissertation. Thank you.
Okay. Okay. So I would shortly regarding to the content of the dissertation work. The thesis provides a detailed analysis and scientific, technical, and patent information literature. The hydrometallurgical technology of processing copper-containing slags has been fully developed in the dissertation research, and methods of containing experiments have been worked out. The quantitative and qualitative indicators obtained in the dissertation on the hydrometallurgical method indicate that the dissertation has acquired the necessary skills and abilities to master this technique. I will shortly read the comments, the dissertation. Firstly, the main objectives of studying the kinetics of the leaching processes are to determine the mechanism and solution of components and to determine the limiting stage of the process, which determined by the calculated of energy activation. However, there is no data on these parameters in the dissertation work. Secondly, the choice of reagent bichromate of potassium is not fully justified. Not fully justified. Yeah. The choice of Taguchi method is not fully justified, although there are many other methods of experimental design. Next, what is the drying temperature after mechanical activation? This temperature is very important for further processes and should be indicated in the dissertation work. Next, some images have very low resolution, and in figure 3.7, the duration of the process written in Russian. Totally these comments.
I need to answer this comment. Okay. Regarding first comments, as was said before, the kinetic parameters of the main reactions of sulfuric acid leaching was shown in table 2. And as we know, the nature of limiting stage of leaching affects the equation of straight line relationship, degree of extraction at the time. Depending on the nature of limiting stage, different equations are straightforward. In our cases, the limiting stage was chemical reaction, and the activation energy was calculated also. Regarding the second question about potassium diachromate, the information about the selection of this reagent was described in chapter 1.5, general information about copper smelter slag in literature review. And from this literature review, we concluded that the potassium diachromate has been presented as a selective, extractive, oxidative reagent in order to copper, and with this using this reagent, there is no need for elevated temperatures than other reagents. The choice of Taguchi method is justified by them that this method is one method that must be considered due to its ability to reduce the number of experimental runs to a reasonable amount. On the contrary to full factorial design, this is an advantage in terms of cost and time, and this methodology is very widely used in using in ball milling processes. What about the drying temperature? About after mechanical activation, the data about this was shown in chapter 2, materials and methods. In the end of the chapter 2.3, the drying temperature was 125 gradius. So about this, I agree with these comments because some pictures have been extracted with old, maybe the main basic principles about mechanical activation, and so these pictures have not so good resolutions because it's the main principles, main basic, because we have basic information about mechanical activations from these pictures. About in figure 3.7, yes, agree about this. It was typos. Thank you.
Thank you. Dr. Baginjanov, what do you say to the responses?
Okay, I think she answered all of my comments. I agree.
Thank you.
Okay, thank you. But do you think these images should be improved to a better resolution?
May I ask? May I answer?
Yeah, is it possible to improve these images to a better resolution?
No, I think if we have better resolution, we draw this picture again, because these pictures were extracted with a book about mechanical activation, and we don't have just remove this information because it's the main information about this regarding mechanical activation. If you want a good resolution, to access good resolution, we have to draw these pictures again themselves.
Mm-hmm. Okay, thank you. So that's about literature review, yes? Not about the results.
Yes, it's about literature review.
Okay, thank you.
But there are your results too in very low resolution, not only literature.
Okay, some results also. What figure can you mention? What figure?
For example, 3.2.
It's about.
Yes, it's about your leaching process and kinetic of leaching process.
I did it. It's in Origin software, and
okay.
I thought that the resolution may be good for understanding the main information about these graphs.
Okay, thank you. So, colleagues, do you have questions to reviewer or PhD candidate? If there's no, okay, thank you. If there are no questions, then the screen is given to the second reviewer, Professor Gabor Muci from the Institute of Raw Material Preparation and Environmental Processing, University of Miskolc, Hungary. Please.
Dear professors, dear colleagues, dear students, and of course, dear PhD candidate who is in the focus today at this defense. First of all, I would like to have the opportunity to reflect your question. This is my privilege to be as a reviewer at your university, at your doctoral school. I'm very happy to get this research work to review. Actually, the topic is really relevant and very actual nowadays when the circular economy and especially the waste recycling is in the focus in the whole world. So, significant research has been launched recently in that topic. Actually, the dissertation is very accurate work and well-written work, and based on a very wide range of literature survey, and the structure is appropriate. Just everything is written, and I don't want to go into details all of the points and issues, but regarding the candidates publishing activity, it can be stated that there are several full-length articles, especially proceedings, and Web of Science journal with impact factor, which is a high-quality journal. And the dissertation contains new scientific results, especially the effect of mechanical activation on the leachability of the specific metal compounds. And based on all this, I propose to submit a dissertation for this public discussion, which is now in process. And of course, based on the relevancies and the nice work, I have some questions and remarks. And now I would like to focus on the most important questions, which can be seen at the end of my review. And of course, the PhD candidate has given all of my questions. So previously, she could prepare the answers. And the first question was related to paragraph 2.1. There was the description of the material, and the original material particle size distribution would be, how to say, very important to see what was the real raw material. And secondly, since this is a very important part of the dissertation, is a comparative investigation. So that's why I suggested to have some schematic drawings of the different mills. And thirdly, in the literature review, there was some confusing reflections for the references. However, these references were the own work of the PhD candidate. So that was nice, but that was some confusing part based on this. And another problem was the unit of temperature. Sometimes was centigrade, sometimes Kelvin. So that was some confusion from this. And as I told you, and I wrote you, specific energy density, or such a parameter which aims to have a better understanding and better comparability of the effect of mechanical activation would be nice. It was related to the future work of the candidate mainly. And there was a figure 3.19, And I would like to ask the candidate that what is the reason of the big portion of coarse material size fraction remained after grinding in the attrition mill and the planetary mill in the samples beside the submicron fraction? So why should remain this high portion of coarse materials on spite of the milling, on spite of grinding, because due to grinding the size is decreasing. Normally, in the case of attrition mill or steel media mill, the material filling ratio should be used instead of bow to powder ratio, which takes into consideration the porosity of grinding media. So for industrial design and industrial scaling up, it would be very interesting and important. And that's why finally I had some confusing abbreviations, but this is only a minor point. So now I would like to ask you.
Thank you for your comments. Regarding about first comment about particle size distribution curve, the particle size distribution of non-activated and the mechanical activated in both mills slag samples was shown in the figure 3.19 in section 3, results and discussion. According to second question about the more detailed description of the mills, this information about about the stress types and the type of mills were described in chapter 1.4.2 of section 1 in literature review, and I assume this information is quite enough for comparison. About the third comment, yes, I agree with this comment. However, yes, most of the was from the papers, from the hours papers. About the fourth comment, yes, I agree with this comment. Uniform unit should have been used. About specific energy density, the main goal of our thesis was to access high leachability with great corpus selectivity. So in comparison about specific surface area after mechanical activation in attrition and the planetary ball mill, we have obtained the similar results, and that's why, as we know that attrition mill is more widely used in industrial scale, we have chosen this is attrition mill because the main goals was on focusing the leachability of the touched minerals. About the sixth comment, this is about the coarse material size fraction. With this is obtained SSA values after mechanical activation. With this is particle size, we have obtained good results in terms of leachability, and it was enough for further optimization of our work, and it was enough information about this. And about the filling ratio, this is a parameter could be calculated from the data given in experimental part, and the experimental part it's indicated that the volume of the treater chamber was 500 milliliter. The mass of the balls was 2 kilograms, and it's about, accounting the density of iron balls, it's about 254 millimeter, and considering the amount of water, filling ratio was about 90%. This value can be easily found from the data presented in the thesis. And about regarding the last comments, I agree with this comment, but on the hand, this is abbreviation is common used in this type of work. Thank you for your comments.
Thank you, but can you go back to this figure 3.19 because I don't.
3.19.
Yeah, can you show the figure 3.19? Because my if you can show and share your screen in the presentation, and I think you can understand what is my question, what was my goal of my question.
Yeah, 1 minute. This one?
Sorry, I cannot see.
Um,
Can you share the screen?
yes, I share the screen.
Okay, I changed to another screen. Yes, now we see.
Yes, this is figure.
Now I can see only the questions. Okay, now I can see.
Mm-hmm.
Okay, this is fine. In your presentation, that was figure 8.
Yes,
And
yes.
as we can see, this is a frequency curve, and not a cumulative particle size curve, as was my first question. But altogether, you can see that due to the grinding, you said that this is a multimodal, a bimodal curve.
Yes.
And at the initial curve, this black curve, that was a multimodal as well, with a higher mode size around 300 micrometer. And in the planetary mill, this 300 micrometer was not changed. Actually, I'm just suggesting you for future work that the cumulative particle size distribution, that would be very important for the description of the size distribution beside the frequency curve. That is just one suggestion for future work. But this curve, my question is related that why not decrease this 300 micrometer mode size due to the grinding? Because you did grinding, and only that curve, this finer mode was, how to say, the fraction is increased around 1 micrometer. But since this is a logarithmic curve, and it might be some, how to say, misleading issues. I don't want to go into details, but my question, why not change significantly the particle size due to grinding? What do you think?
Mm-hmm. I think we have different conditions for mechanical activation, and we have obtained different specific surface area values. We have a different rotation speed, and ball-to-powder ratio, filling ratio, and about duration of mechanical activation. In these cases, the duration for both was in a medium. It's about 75 minutes, and for rotation mill, it was about 13 minutes, 75 and 13 minutes. So I think this is the duration maybe could affect for this is the distribution of the particles. But however, the main results, the final results, in order to investigate the leaching, this is results obtained from both millet samples were enough to further investigations regarding leaching. I think it's yes.
Okay, this is enough. This is enough, you think? But another suggestion that a kinetic approach for the particle size distribution as function of energy or residence time would be important, because if you just put 2 ground sample particle size distribution, especially frequency curves, you just see an actual state. And due to the effect of these 2 high energy meals are normally affecting very fastly. So in the first minutes of grinding, the particle size decreased dramatically. So it just was a very surprising that this particle size is so coarse. Or the other hand might be the aggregation or agglomeration. So that would be another alternative, that after 30 minutes and 70 minutes of grinding, the particles are aggregated, as well as the attrition of the surface particles, the small particles, the submicron particles are formed, and that would be another alternative. Or as I remember, the size of the grinding media was 2 millimeters.
Yes.
In both cases, yes?
Yes, yes.
That might be another problem, since in the case of energy, grinding energy, the coarse particles are normally crushed by impact or pressure. So maybe this small particles has not enough energy for making the mainly bigger particles, and it might be another issue. But since I don't see the whole kinetic of the size distribution, this is hardly to investigate just from here. So thank you very much for your answers.
Yes, thank you. You said about agglomeration, but this agglomeration is common in dry milling, yes. But in this case, we had wet milling, and so is it possible? Is it how to say? Is it possible to explore this in terms of wet milling?
Okay, just you are speaking about aggregation or agglomeration?
Yes. Agglomeration.
Agglomeration.
You said about agglomeration.
You said that agglomeration not takes part in high energy density milling, even in wet state. You said?
Yes, yes.
It might be.
Okay. Okay.
Agglomeration can be taken to the fossa. It might be takes place.
Okay.
In wet milling as well.
Okay. Thank
you.
So
that would be how to say, a deeper investigation in this size distribution. I think this is not your goal of dissertation. Not your goal. So it doesn't how to say decrease the value of your whole dissertation, but a more careful size distribution investigation might be of interest.
Okay.
So altogether, I support the PhD degree after a successful defense. So I absolutely agree, and I absolutely satisfied with the whole work, based, and of course, in spite of some questions. So thank you very much for your attention.
Thank you, Professor Muti. And do you have questions to Professor Muti? Okay, if there are no questions, then let's proceed to the next stage. And now we should have a discussion. Who wants to speak? To tell some comments, opinions about the work?
Let me start, Bulat.
Okay, yes, Professor Burkitbayev, please.
Just recently, I read the interview made by one of billionaires of Kazakhstan, and his business is deal with the copper production. And he predict that copper become to be instead aurum. It means the cost for copper is growing year by year. And of course, the businessmen look to that process from the point of cost. And for us, it is a reason to searching the ways how to increase the recovery of copper from the slugs. And until today, I know that all kinds of slugs are usually used for as additive materials for producing binding materials in the building industry. And I very much like that in my university, decided to use slag as a source of copper. And as you note that Lezat demonstrated well knowledge in the field of your investigation. And also she's fluent, I know, in 3 languages. Now she defends her thesis in English and Russian, but also she speaks well in Kazakh languages. And so that way, without doubt, I will vote and support this study. And also, I would like to note that we have to be more careful with the term of technology, because technology is a very complicated process which collect together balances from raw materials, productions, and also calculations from the economical point of view. And usually technology is the object of the institute working. This is just my note. We be more careful with the terms technology. Thank you so much.
Thank you. And who wants to speak? Maybe Dr. Kolesnikov, do you want to tell, because you are the temporary member? We would like to hear your opinion. Александр Сергеевич, хотели бы ваше мнение услышать тоже, если возможно.
Здравствуйте, уважаемый член диссертационного совета, уважаемый председатель, уважаемый секретарь. Значит, работа очень интересная, заслуживает внимания, извлекаются цветные металлы. Хотелось бы услышать, какова комплексность извлечения вообще металлов и каков остаток. Что предназначено, значит, для остатка, что будет с ним, как будет он использовать комплексность всей переработки данной технологии. Вот этот момент интересует. В целом работа интересная. Я поддерживаю работу данную.
Хорошо, спасибо.
Спасибо большое. Насчет комплексности мы предложили двухэтапную схему переработки, гидрометаллургической переработки. На первом этапе мы извлекаем медь при оптимальных условиях выщелачивания и при условии, что шлак был механоактивирован при оптимальных условиях также. В этом случае, значит, в первой стадии мы извлекаем медь. После у нас остается остаток. В этом остатке у нас большое количество железа и цинка. На второй стадии мы уже доизвлекаем цинк, железо и медь тоже. Также при извлечении цинка мы, получается, осаждаем железо в виде ерозита, в виде осадка. Таким образом, мы берем раствор, именно преобладающий с цинком. После этот цинк, получается, тоже можно будет тоже осадить сульфидированием, а медь цементированием и так далее. Получается, в результате мы в первой стадии получаем медь, а во второй стадии получаем цинк.
Это понятно, да, двухстадийное у вас выщелачивание, первая стадия, вы цинк извлекаете, потом медь и железо. То
Да.
есть цинка там порядка 5%, меди 1%, да, вот как вы изначально показывали в слайдах.
Да.
Железо порядка 35-36%.
24-22 вот так процента железа.
22, да, вы говорите? Вот. Значит, железо извлекается на сколько? Степень перехода железа?
Железо извлекается тоже на 50%, как же и цинк, но мы в этом случае должны как бы селективно извлечь цинк, поэтому мы его будем осаждать в виде ерозита. Где-то 50% цинка у нас осаждается в виде ерозита.
Хорошо, а вот с оставшейся частью что вы планируете делать, то, что осталось?
Там, получается, у нас в остатке этот остаток, он содержит некоторое количество железа, цинка и меди, и кремния тоже. Оно дальше используется как материал как строительный материал, в основном, как и шлак использовался, и хвосты, вот то же самое для остатка после выщелачивания применимо.
Спасибо.
Спасибо.
Хорошо, спасибо. Окей. Булат Кунурович, пожалуйста.
Диссертационный совет, уважаемый председатель, коллеги уважаемые. Сегодня мы заслушали очень хорошую, оборотную работу, которая как и в теоретическом плане, так и в практическом плане имеет большое значение. Диссертант, она, значит, выполнила большой объем работы, и использовала современные методы физико-химических исследований. Я хотел бы обратить внимание на ту часть еще, кроме я задавал вопросы. Здесь я вот обратил внимание на микрофотографии, полученных в результате механической то есть получения частиц на планетарной модели. Практически получается, диссертант работает на наноуровне. Дело в том, что там я обратил внимание на размеры частиц, где-то порядка 200-300 нанометров. Современное сейчас толкование наночастиц, особенно одним из крупных специалистов в области нанохимии, академиком Третьяковым Юрием Дмитриевичем, это, знаете, это один из крупнейших ученых в области неорганической химии, нанохимии. И у него есть как раз определенная теория, которую он распространяет наноуровень до несколько сот наночастиц, как наноструктурированные или нанокластерные. И в этом плане как раз, что она получила результаты хорошие, это практически получается тут и металлургия, и нанохимия, и физическая химия, и, естественно, предложена технологически такая хорошая схема. Дело в том, что всем известно, что у нас месторождения цветных металлов истощаются. В свое время было 2% медные, такие руды, их сейчас уже, они все переработаны. Сейчас большие отвальные шлаки, как раз это диссертационная работа, как раз занимается вторичными сырьевыми ресурсами и получает, в общем-то, хорошие результаты извлечения цветных металлов. Я полностью одобряю эту диссертационную работу, она поддерживаю что в присуждении степени доктора философии. Хотел обратить такие незначительные, может быть, при оформлении окончательном, учесть такие моменты. Во-первых, тут двойная дихромат, надо единая терминология, либо бихромат, либо дихромат. Второе, значит, вы пишете список литературы, патенты, просто опубликовано пишете. Надо указать, опубликовано в госреестре, где-то в каком-то бюллетене изобретений, госреестр. Это технически, но это нужно. Потом, мне кажется, надо указать, у вас много технологических экспериментов, физические эксперименты по физической химии, указать погрешность. Погрешность – это этих полученных результатов. И технологическом у вас много анализов сделано, а также и кинетические параметры. Там должно быть, значит, где-то, хотя в тексте указать, погрешность определения эксперимента и так далее. Потому что достоверность полученных результатов Это с учетом математической статистики, это усиливает работу. Я полностью одобряю и то есть поддерживаю работу, данную диссертационную работу. Спасибо.
Спасибо. Okay, colleagues, who wants to speak? So, unfortunately, we have one temporary member switched off because of some internet connection problems, probably. But somehow we should get him back because he must be present. Dr. Hassan Arslanoglu. Unfortunately, he's not present. Okay, I will tell my opinion about the work. So the work is very, very good, very important, and the results are, let's say, promising. There is a publication in a good journal from first quartile in Web of Science, which is very good, and Ms. Musapirova has the first authorship in this paper, so which is also very good. Yeah, however, there are a few comments from my side to the work, and first of all is which was already mentioned, that error standard deviations. There is definitely lack of this data, because if you compare some results, you always need to look at the standard deviation, because the difference can be in the range of standard deviation. So it will be statistically insignificant, because you always compare something, it should be there. Yeah, and the error which you said, like 0.05%, it's really impossible, even for direct injection to the instrument, because there is an error in calibration, etc. It should be at least like 1%. But for experimental extractions, let's say, the standard deviation can be like up to 5% or even more. Yeah, because it's experimental difference. There is a difference between experimental samples. There is slight difference in the experiment itself. Yeah, so this information should be provided, really. Okay, and another comment is the novelty. So novelty should be clearly stated, because these comments were provided. So a good comparison should be provided with other available technologies, because it's technological work in engineering, in chemical engineering. It's mandatory to provide the comparison. Yeah, and the comparison should be very clear. So in my opinion, these are main features. But generally, the work is very good. But I still think that some errors, which were already also mentioned, should be corrected. And now there is a possibility to correct these errors. And I just want to briefly show you one slide, let's say. It was the requirements for the defense. Yeah, so there are like four possible decisions. First is to award the PhD right now. Second is the sent for revision. This is in the case of minor comments which do not change the essence of the work. Yeah, second is the sent to a new defense, like redefense. In this case, if we have like in conformance with the publication, but here I think everything is okay, and also partial inconsistency with the principles of novelty, internal unity, and reliability. In my opinion, it's also okay. So there is no reason to send for a new defense, really. Yeah. So in my opinion, there are some minor comments which should be improved in the dissertation, so, which were also mentioned by other colleagues. Okay, these are rules which we have to follow, like when we make a decision, when we vote. Sorry. Okay, so what about Dr. Arslanoglu? Sagdat Midilbekovna. So because we need him.
He have a problem with has a problem with internet, and he trying to connect.
Should we wait because the next stage is voting? Yeah, so we cannot proceed to voting because he is not here. So we have to wait until he appears. Maybe other members of dissertation council want to speak. Dr. Chepushtanova, maybe you can provide your opinion about the work because you asked a lot of questions, very good questions. Maybe you want to comment the work. Татьяна Александровна, вы на связи? Because the video, I asked not to switch the video off because we are in the broadcasting, recording, etc. Татьяна Александровна.
Сейчас она в данный момент немного отвлеклась, ее позвали. Что делать, а? Сейчас. Так.
Yeah, because there is a rule that all reviewers and temporary members of dissertation council must be present during the defense. And we should follow this rule, let's say.
Can you send this mail voting bulletin, да, voting bulletin.
Тогда Пидебековна, может, позвонить можно? Позвонить.
Он написал, я ему пишу. Сейчас. Так, хорошо, давайте вот это наберем. Сейчас, ага, я пишу секционал, да? Секционал, да, и плюс он секс, Чернобыль.
Okay, he is connected.
Сейчас.
И Татьяну Александровну надо попросить подключиться и высказаться по работе. Как временные члены, ну, очень важная идея. Очень важно услышать мнение. Окей, доктор Arslanoglu, can you hear us?
Нет, пока.
Okay, yes, we see you.
Что теперь делать? Так, может, позвоним сейчас. Хорошо, попробуем, да? Так, сейчас. Все промосло, вот так и наберем. Да? Зашел. Хорошо, зашел. Ага, замечательно. Вот, Нурланович.
Hey, Dr. Arslanoglu, can you hear us?
I am sorry, cannot with telefonla bağlandım.
Okay. We would like to hear your opinion about the work.
Thank you, researcher. and his advisor request the thesis to be accepted with the minor errors.
Okay, because you know I just showed you the slides for the
No slides, no slides, PC.
So you suggest to send for revision or what? Or because there is, if there are minor comments, it should be sent to revision, minor revision. Yeah.
Excuse me. How is the leaching mechanism of this work? Question question 1. How is the leaching mechanism of this work? Question 2. What other chemical can be used instead of the chromate? Question 3. What effect did mechanical activation have on bed surface area? Thank you.
Okay, thank you. Lezat Arkhatovna, can you answer these questions? Did you understand?
Yes, yes.
Okay.
The first question was about leaching mechanism. About leaching mechanism, it's about dissolution of minerals in sulfuric acid solution. It's about that sulfuric acid as an oxidizing, strong oxidizing agent. It acts in order to react with minerals in the high concentration of the sulfuric acid solution. This was the mechanism. It's silicate. It's a solution of silicates, ferrites, and chalcopyrite. About the second question, it was about biochromate. Yes, about potassium biochromate. This is about the potassium diachromate on specific surface area. Yes, the relationship with these two parameters, as I understand.
Yes, okay. Thank you.
Okay, thank you. Okay, if there are no other speeches, let's move to the next stage, which is the voting. So now you will receive the members of dissertation council and the reviewers will receive the invitation to vote for the dissertation. Yeah, and you have to vote for one of the 4 possible options. Okay, and now we should have a break for voting. It should take like 5 or maybe 10 minutes if everything goes smoothly. So please vote, and just don't tell how you voted, because this is like secret vote. Okay, break for
we
the
have
vote.
sent. Bulletin.
Thank you.
Извините, можно уточнить? А какую почту вы мне отправили? Я пока... не пришло пока.
Хорошо, мы на другую отправим сейчас.
Вам на Gmail отправили.
Да, всем на Gmail отправили, но если нет, то на...
Пока не пришло, не получилось.
Хорошо, тогда на другую почту.
Смотрите в спаме. So the letter maybe can get to spam folder. Just check your spam folder. And just please vote only once. Тогда Медибек надо на все почты отправить. Там с любой почты можно голосовать.
Да, да, конечно, да.
Главное ссылку доставить.
Да. Комиссар Сабжанова отправили вам.
So did everybody receive invitation?
Ага, сейчас. We are waiting for one answer. Сейчас. Сейчас. Сейчас.
Пока еще не пришло. Я вот каждый раз обновляю, тут не видно.
Да. И Gmail нет, и там нет, да? Хорошо тогда. Сейчас.
Можете на WhatsApp лично отправить, это там одна же ссылка общая, чтобы быстрее было. Так, Медведь, на WhatsApp отправьте.
Да. Сейчас. На WhatsApp отправили.
Окей, Сагдат Мирбековна, как готовы результаты?
Да, готов. Сейчас я посчитаю. Вот, сейчас.
Хорошо, дадите знать. Ага.
Да. Раз. Два.
Matei, nice to see you. Thank you for your collaboration. Your very active work for support our youth.
Thank you very much, Professor Burkitbayev. Yes, I am very happy to collaborate with people in Kazakhstan because I can see that they accept my advices, and it's not like talking to empty wall, but I can see they respond, and it's very also good for me. I am very happy that I can share my knowledge with people here.
Готовы?
Great.
Готовы. Вот, Нурланович.
Okay, colleagues. Let's continue our defense, and this screen is given to Professor Tajibbayeva to report the results of voting.
Dear colleagues, decision of our dissertation council for defense of Mусапировой Л.А. dissertation. You have results. Our results consist decision of 10 members of council, and among them two members voted for send the dissertation for revision, and 8 members voted for to award the degree of the Doctor of Philosophy Musapirova, to Musapirova.
Okay, thank you.
2 and 8.
Okay, so 8 voted for the awarding the degree. Okay, thank you. So based on the defense and the results of the voting, yes, so the dissertation council makes a decision to award the degree of Doctor of Philosophy to Лязат Мусапирова on the specialty of chemical technology of inorganic substances. So my congratulations to Лязат and her supervisor, and I would like to thank all dissertation council members and reviewers for very productive and interesting defense. Thank you very much.
Thank you very much.
So I give the last word to the PhD awardee. So please, Лязат.
Thank you very much for your considering about this word. Thank you very much for your time. Thank you to all members of dissertation council, and I want to say great thanks to my scientific supervisors for their great support, and for the advisors, and for the great work was related with my PhD thesis. Thank you, all of them. Thank you very much.
Okay, thank you. Thank you very much, dear colleagues. And we finalize our defense. I stop the broadcasting, and thank you, and see you next time.
Bye.
Thank you.
So, Lizat, congratulations you and your supervisors. It's really very excellent.